My name is Kim, and I'm one of the recruitment coordinators for the Fulton Schools of Engineering. I'm actually housed out of the Polytechnic campus. And with us today, we actually have two amazing professors with us that are going to talk all things computing with you guys. So how it'll work is they'll do a presentation, and then we'll open it up for question and answers at the end. You will notice there is a chat feature. It's been disabled, so don't try to communicate with us in there because we won't be able to talk back with you. However, there is a Q&A feature. So if you want to pop any questions in there, any that you think of maybe while they're discussing, and then we will answer those at the end for you guys. So with that, we'll go ahead and get started. Which I don't remember which one's going first.
You go first, Ryan.
All right.
Okay.
Hi, everybody. My name is Dr. Ryan Muth, and I am a senior lecturer at the Fulton Schools of Engineering. I teach the Intro to Engineering courses mainly, and also in the spring, I teach computer systems engineering courses.
And I'm Phil Miller. I'm also a senior lecturer in SIDC, and I teach the freshman engineering courses and the intro level computer science courses, programming courses.
Awesome. So what we're going to talk a little bit about today is the different majors in the CIDSE department. CIDSE stands for Computing, Informatics, Decision Systems Engineering. And the umbrella that this department covers is computer science, which is offered at Tempe. We have a concentrations in information assurance, which is also known as cybersecurity, as well as a concentration in software engineering. We offer a degree in software engineering itself at the Poly campus and online. We have a degree in computer systems engineering, which has more of a hardware focus at the Tempe campus with the same information assurance or cybersecurity concentration. And then also informatics at the Tempe campus, industrial engineering at the Tempe campus, and engineering management at the Tempe campus, as well as offered as an online degree program. So one of the big things here is these are a lot of degrees, right? And there's a lot of things that sound very similar. So what we wanted to focus on is sort of the difference between computer science, software engineering, and computer systems engineering, right? So the first thing is that a lot of these degrees, all of these degrees, focus on core programming skills. So what they have in common, what is the same between them, is the Intro to Programming class, CSE 110, data structures, 230, which is computer architecture, 310, which is data structures and algorithms, and stuff like that. So this is the core set of programming skills. All of these degrees take, if you enroll in it, in any of these, all of these degrees take the same core programming sequence and get that core set of skills. Where they diverge is further into their degree programs. So Phil, you want to talk about what sets apart computer science?
Yeah, computer science is kind of it's more focused on the theoretical aspects. It's about what is computation, what kinds of systems can we design that can compute, and then what things are computable, because it turns out that not everything is amenable to computation. We can't solve all problems through computation. And then the problems that we can solve through computation, computer science looks at how can we solve them efficiently in terms of the amount of work that we have to do and the amount of resources that we would need to apply to solve those problems. So algorithm design and analysis is a big part of it. Data processing, you've probably heard the term big data. There's a fairly heavy focus on mathematics because of the theoretical underpinning, and computer scientists are often kind of in that forefront in building the tools that your software engineers and your computer systems engineers are going to leverage.
And do you want to talk about software engineering also?
Yeah, sure. I'll talk about software engineering is more on the applied side. So while the computer science is more theoretical, software engineering is about what can we do with this? What real world systems can we build that actually help people solve problems in our world? So the applications that you're used to dealing with on your mobile platforms and on the web and your desktops, even your gaming systems, all the software in there is mostly designed and implemented by software engineers and software engineering teams. And you can view this as a kind of more of a craftsman kind of perspective. They're the ones that are designing and building software systems using the algorithms and fundamental tools that computer scientists have created.
Yeah. And then computer systems is sort of the hardware focus of these same disciplines. So the idea here is that we, as computer systems engineers, employ the tools and some of the same techniques that both computer science and software engineering do, but our focus is on the bridge between the digital and the physical world. So anything that interacts with the real world, anything that is a program that lives inside of a product, like the thermostat in your house is running a tiny program designed by a computer systems engineer that's only job is to read the temperature, read the button settings, write a little bit of information to a display, and to decide whether or not to turn the heating or air conditioning system in your house on or off, right? And that little program is specifically purposed for that. Other things they might do is things like the drivers for your graphics card. They're developing the low-level hardware that gets all these pieces, or the low-level software that gets all these pieces to talk to each other. Stuff like that, right? So they're kind of like the utility worker. They're behind the scenes. They make sure that all the systems are talking to each other so that these higher-level systems and algorithms can work together to solve like human-style problems. So for example, at Amazon, something you might see for like a computer scientist might be somebody that's working on the recommendation system. So when you choose or search for a product, there's an algorithm that's running in the background that is saying, okay, based on the history of the things that you've looked at already or the things that you've bought before, what have other people bought? What is the recommendation? And this might be based on artificial intelligence, or it might be based on a simple probabilistic model or something like that. But a computer scientist worked on how to design that algorithm and analyzed its behavior to see if people actually buy things off of that list, or if it's irrelevant or something like that. So there's a significant component of like data analysis and working with data and designing algorithms to manage large amounts of data.
The software engineer, on the other hand, is probably going to work with the components of the system that the user is more likely to interact directly with. So again, if you're shopping on Amazon and you choose a project and put it into your shopping cart, that whole experience, what moderates that experience and makes it real is because of the systems that software engineers designed. So you have an account on Amazon, and the software engineers have designed a system to allow the creation and the management of that account. And when you're interacting with the online sales system and you select a product and you put it into your cart, it goes into your cart. And when you click buy, it charges your credit card and that kind of stuff. And so software engineering is, again, it's a little higher up on there. And, you know, how are we applying the recommendation system? And how are we building that into a larger system that humans are going to interact with more directly?
Yeah. And the computer systems engineer, if they're working for Amazon, they might be doing things like designing the circuit board that goes in the Alexa physical products, or the software that lives on board the Alexa product to recognize when people are speaking to it, or to sample the audio information from the environment, recognize the Alexa wake words and stuff like that, and then communicate with Wi-Fi and send that information to the Amazon servers, and then get the response back and play the audio and all kinds of stuff like that. That's software that's happening very close to the hardware of the product. So it's something like super low level, and it kind of runs in the background to provide that service that other people like the software engineers and the computer scientists are designing.
I think it's interesting to point out too that while there is differentiation here, the Venn diagram that we have here shows a lot of overlap, and it is fairly common for students who graduate with one degree to kind of shift their career over time, and might move from a software engineering career to a computer science career, a computer science career to a computer systems engineering career, or computer systems engineering career to a software engineering career. So you're not locked in, like that core skill set of programming and understanding what a computer is and what a computer can do and how do we get computers to do what they can do is a very powerful skill set that gives you a lot of latitude in your career.
Totally. So for the informatics program at ASU, informatics is focused on the management and presentation and analysis of large amounts of information. This can have a specialty in a lot of different areas. Our computer science, our informatics program focuses on sort of the human interaction side. So how do we present information? How do humans make decisions based on information and how it's presented? And then how do we actuate that and give feedback to people about how that has gone and how do we design these interfaces and the presentation and management of large amounts of information for people. So it focuses mainly on technologies where human and computer interaction occurs, and it uses a lot of the different other majors. This one is sort of a umbrella as well, and some people will say, oh, it's like computer science light, but there's actually quite a bit of programming that still occurs. We use in the informatics program, we use Java as our main language, and there are a huge amount of different areas that are affected by this, like game development, web technologies, mobile app development, all kinds of stuff like that. And I think Phil really likes to talk about this diagram.
Okay. Yeah. So again, that sort of, there's a spectrum on the one end, computation is a physical process, right? In order for a computer to compute, physics is happening. When we say ones and zeros, we're talking about bits on a theoretical perspective, but on a physical perspective, we're talking about transistors, which are fundamentally switches, which are allowing electricity to flow or not flow. That's the ultimate end of the spectrum towards which computer engineering is working. They're trying to figure out how can we use fundamental physics and build up from there and build systems that compute in ways that we want them to, efficiently, both cost efficiently and energy efficiently, and do it without overheating and that kind of stuff. Computer science, and again, there's overlap here. Computer science applies what the computer engineers are doing, and they're looking at, okay, how can we now take these systems that compute and get them to compute interesting and useful things in an efficient manner? And then software engineering takes that a step further and says, okay, how can we use these to build systems, design and build systems that solve real problems for people in the real world? And then informatics people are looking at that more from the human perspective and saying, okay, this works, but how do we make it something that people want to use, right? And maybe an example of that might be, most modern automobiles have an in-car sort of entertainment / information system. There's a touch screen in your car. There's an iPad in your car. How do we design that in such a way that it's useful, but not going to get you killed on the freeway, right? We don't want you like squinting and trying to fiddle with some tiny little doodad on the screen. We want to make sure that the buttons are big enough and differentiated enough that you can effectively use these features in a safe and effective manner.
Awesome. Informatics people go into careers the computer scientists go into careers doing things like data scientists, if you have an emphasis in artificial intelligence and statistics, or another big area that our graduates go into is software quality assurance. So it's writing and testing software that makes sure that software is up to snuff and it does what it says it's going to do, and it's not going to give errors that cause disasters and stuff like that. Software engineering, you go for job descriptions. There's things like developer, which is a very broad category of people, and you can specialize in things like web development or mobile app development, or even project management, which is sort of later down the line after you get some experience that a lot of software engineers may end up there. Different fields of software development that go with it. And you can sort of specialize within those, taking the elective classes that we offer here. Computer systems engineering, we end up, so I'm a computer systems engineer or computer engineer. by training. And the things that we end up doing are things like hardware design engineer or embedded designer. We design the embedded systems like the Alexa hardware, like the remote control for your TV, like the graphics card that NVIDIA makes, the card itself, not just the chip, but also the chip and the software and firmware for it. Later on down the line, you might be a systems architect where you're managing a large project and how all the pieces fit together. And we work with we work at networking companies to develop the switches and the switching technologies and crank every last little bit of performance out of whatever hardware we have and try to make it as cheap as possible so that it's affordable and performant for anybody that ends up using it. Do you want to talk about industrial engineering, Phil?
Sure. Yeah, I'll give that a swing. I'm not an industrial engineer, but let's hit that next slide. So industrial engineers, so there are a lot of processes in the world that operate on large scales, production, steel production, or automobile production. And they operate at such scales that, whether it's Tesla or Ford, you're going to have computers in there. So computer engineers are going to be a part of that. If there's computers in there, then there's going to be software. So you're going to have computer scientists and software engineers in there. And computers don't run without power. So they're going to be electrical engineers involved. And of course, automobiles are fundamentally mechanical systems. So they're going to be mechanical engineers involved. And bringing all these things together and designing systems that allow us to, say, for instance, set up an operation where we can effectively build automobiles at scale. That's something that an industrial engineer would be interested in. How do we design that process, that system that then allows us to construct automobiles that are safe and reliable and cost effective?
Mm-hmm. Yeah. So industrial engineers work in all kinds of different places where processes are to be optimized. A great example is waiting in line at Disneyland, right? How do we make that experience less painful for people? So what they did is they figured out ways to provide information to people. If there's a long line at one ride, they try to provide information to people so that they say, oh, hey, the lines are real short over here. Or they designed the line following area itself so that it moves a little bit faster or it's less distracting and people feel better. Facility layout design. How do we make sure that for the processes that happen in a manufacturing shop, that people aren't crossing the facility many times, that the next step in the process is close by, and that makes it more efficient. There's less overhead for moving things around. How do you lay out the facility? If you're doing a bunch of different processes, how do you lay it out to make it the most efficient for all of those and increase your production while lowering your cost? Quality engineering, when do we test things? How often do they fail? How do we do quality control on things like food and stuff like that? Stuff that it's really dependent, not just to get it right, but that people are eating it and consuming it and their lives depend on it. Routing and networks is super common. How do we get your UPS driver to make make the most number of stops in the shortest amount of time, right? How do we determine a route so that they are efficient and they're not driving all the way across town a bunch of different times? They can drop packages off, unload their truck and get it done quickly and get it done efficiently so that they use less gas. There's less wear and tear on their vehicles.
How do we make sure that all the mail-in ballots get counted on time?
Yeah, that's right. Another thing that they use a lot is simulation. So what kind of how do we do emergency evacuation plans without actually panicking a stadium full of people, right? So we model the behavior of simulated people, we put them in a stadium, figure out based on the locations of the exits, how can we direct them to places and get them out of the stadium as quickly as possible if something terrible happens.
Logistics is a big part too. Yeah. And I was in the military a long time ago, and when they're moving troops, when they're moving armies around, it's the equipment has to be moved. It has to be there before the troops get there. There has to be food that's supplied. When the troops move, we have to make sure that their food supplies and their ammo supplies and their fuel supplies move with them, right? And if they need medical care and that kind of stuff. So it becomes a huge issue of how do we get resources where they need to be, when they need to be there, in an efficient way. So that we could just, be wasteful and make sure all resources are available in all places, but then we would have a lot of resources that aren't being used or being underused. So how do we efficiently use the resources we have so that they are where we need them to be when we need them to be there? Healthcare, diagnostics and scanners and utilizing the equipment. We have a limited number of X-ray machines and a limited number of MRIs and a limited amount of qualified professionals who can use these machines. And then we need people who, we have people who need these machines in order to diagnose medical problems. How can we reduce their wait times in the emergency room so that they can be treated more quickly and more effectively? These are also industrial engineering concerns.
And this major is very broadly spread across a huge variety of industries. The defense industry, shipping industry, all the things we talked about, all manufacturing industries employ industrial engineers because they have a manufacturing line and they want to make things as cheap as possible at the highest quality possible. We're optimizing processes to do that. The airlines employ a lot of industrial engineers because they have a changing process. They have loading and unloading people. They have changing air flight schedules. The demand changes depending on the time of year and holidays and all kinds of stuff like that. They are continually trying to optimize their schedules and routes. Engineering management is a sort of related field. And in this part, we're looking at how do you manage teams of engineers to how do you optimize the process of teams of engineers and how they work together and how they deliver on time. So this is much more of a project management sort of degree. And what's really interesting about this one is that it offers a baseline of sort of engineering education knowledge, and then you can specialize in a field while also learning the project management and project while learning project management skills. So you would take a class, take engineering management, project management classes in SIDSI, you would take some fundamental engineering stuff, but you could specialize in computer science or electrical engineering or mechanical engineering or something like that. And you take those classes, get those fundamental skills, and then be able to communicate with diverse teams or teams outside of computer science or anything like that. We kind of ran over these. This major is really, really important, and a lot of people go to work for it. And you get some basics in accounting, economics, finance, management, and leadership. And they, again, go into a huge amount of fields. Basically, all engineering fields have engineering management needs because they're doing engineering projects. And that's kind of where you end up. And it goes all over the place. So that is the gist, and we just wanted to give you an idea of sort of what the different majors are and sort of the differences between them are, and we're happy to answer any questions that you guys have with the rest of the time we have.
Yeah, so if you want to use that Q&A feature, you can type any questions in there, and then we'll be happy to answer those for you. So we'll wait a few minutes and see what questions we have. First question is, what would be the best major for someone with an interest in both computer science and information technology?
I think you couldn't go wrong. Just off the top of my, I would have to ask you some more questions, but computer science obviously is a good major. Informatics is probably also a good major for that interest. And I think you have the opportunity, no matter which of those majors you might start out in, to explore a little bit. And then within a semester or two, if you feel like you want to shift your focus, I think you could effectively do that without making any real changes to your degree plan. And then you could also possibly apply some of your electives to kind of hone your focus.
Absolutely.
Great, thank you. Any other questions? How basic does the software engineering program go? Should I learn a programming language before I begin?
That's a great question, and it's very common. One of the ways that one of the things that all of our programs do is we assume that you're starting from nothing. People that we expect to come into this class are just interested. There doesn't have to be, you don't have to have any experience in programming. We start everybody from zero. And even if you have some experience in programming, you've probably learned some bad habits, and we want to make sure that we correct those during those early classes as well. So we want to provide everything that you need to be successful as a programmer in the bachelor's program. So you shouldn't need to learn anything ahead of time. You can get a little bit ahead, but it's not certainly not a requirement. You can very much be successful without having any experience.
What kind of networking do computer systems engineers do?
That's a really good one. So part of the computer systems engineering curriculum is some networking classes where you work with the low-level software of networking things. So it's like working with networking, working with routers, working with switches, working and writing software that communicates between computers over a network at a very low level. So it's stuff like opening a TCP socket and sending a message to another computer on a different network, and how do you navigate the hops between, and how does it work, and stuff like that.
And what if someone's interested in going into AI? What major should they focus on?
Computer science is probably your best starting point there, because AI is still, I mean, while we're starting to apply it really effectively, I think, it's still a very theoretical thing, and computer scientists are on the cutting edge of that.
Absolutely. And in our program, the AI classes are electives. So even if you're in software engineering, or if you're a computer systems engineer, you've got room in your degree program to take these sort of specialty classes in artificial intelligence and machine learning and stuff like that to sort of explore, if you want to do those things, and focus in on some of the fields that are in computer science and programming.
Great, thank you. Any other questions? These are great questions, by the way.
These are, yeah.
What does a system architect do in the scope of computer systems engineering?
So system architects are sort of the people that design the high level interfaces for systems, and then the people that they work with are going to sort of implement them and support those high level interfaces. So a system architect for Alexa might say, okay, we need a networking interface, and it should be connected to the main CPU, and then there's going to be an audio processing unit, and this is how we see all of those pieces connecting. And I'm going to supervise this team of people that specialize in networking and audio processing and basic CPU design. And I will be watching how they talk to each other, and have enough knowledge about each of them that I can make sure that they're talking to each other and working together well. So a system architect in computer systems engineering is kind of like a project manager for a hardware project that's looking at how all the pieces come together.
Another question is, are there lots of internships available through, we'll say, Fulton Schools? Yes, there are. So we have a career service center on both the Tempe and the Poly campus. And so those people in there, that's what they do. They help you with resumes, job interviews, internships, really that career industry connection. So absolutely a lot of things available for you.
Do a very good job. A very high, I don't know the numbers exactly, but a very high percentage of our students have an internship by the time that they graduate, and most of them get placed in jobs following that.
Okay, great. If I wanted to get into computer programming from game design, is computer science a good place to start?
I think so. I think computer science is a good place to start. I think that computer informatics is also a good place to start. It's going to depend on whether you're more interested in the kind of, if you lean a little more towards the user experience side of things, I might encourage you to explore informatics. If you lean a little more towards the algorithms and the code, I would probably encourage you to go computer science.
Okay, the next question is, does computer systems engineering intersect with information technology a little bit?
Not a whole lot. I mean, there's a lot of commonalities and there's some commonalities in the topics, like the networking class that we talked about. But information technology is going to be much more focused on sort of the higher level networking systems, and the computer systems engineers are going to be focused on the low level networking systems. So the information technologists would learn how to configure and build networks and get computers to talk to each other and how to automate those processes on a very, very large scale. Whereas the computer systems engineers are looking at, how do I write software and firmware for the router itself? So they would be thinking about much more like, here's a particular application running on a router. Here is the router itself. Here's the hardware and networking information that's happening at the lowest level. So it's a question of scale. They overlap in the scheme of things, but they're very different degrees.
Any other questions? If you start with software engineering at Poly and want to change your major to computer science, do you have to go to the Tempe campus? So how our programs work is we don't duplicate those majors. So whatever degree program you choose to study will then determine what campus you are a student at. So all of your classes for computer science will be at the Tempe campus, and then all of your classes for software will be at the Poly campus. So if you do change your major, eventually, if let's say you're at the Poly campus, you could take your gen ed there, but you would eventually have to go to Tempe because that's where those classes are housed at for that major specifically. But students do that. Students change their major often, and it's a pretty seamless process as well. Would it be hard to double major in IT and computer science? Do you guys want to answer
that question? Is, any Fulton degree is a non-trivial undertaking. I would expect it to be challenging for any qualified student. Adding a second degree to that adds challenge, yes.
Yeah.
Is it doable? Yes, students do it.
Yeah, I think so. The IT degree, I think that's offered out of WP Carey, right?
No, the information technology is out of the Poly school, so it's under Fulton, but it's at the Poly school.
Okay.
It's not part of SITC, so.
Yeah, I think because of that, there's not a lot of overlap in the major maps. So you would end up taking a lot of other classes and you wouldn't be able to double count them for the 2 degrees. And that makes it a lot more work. So I would make sure what you can do is you can go on the CIDSE engineering website, cidse.engineering.asu.edu. And they have major maps there. You can do the same thing for the Poly IT degree, and I would look at the class numbers on those 2 maps and make sure and see what the big differences are. Or you can talk to an enrollment advisor if you're on the way.
Again, doable, just a lot of time on your part.
Yeah. Worst case, it's double the work.
I think if you're considering something like that, I think something else to consider would be the 4+1 program.
Yeah.
which will get you a master's degree with an additional year of study.
So just in case you don't know how our 4+1 programs work, it's really a way for our students to walk away from ASU in 5 years with their undergrad and their master's degree completed. How we work that is each major has a minimum GPA requirement for you to maintain while you're a student at ASU in your undergrad program. If you meet that, then your junior year, you can apply for the 4+1 program. Once you get admitted, you essentially have 1 year of school left after you graduate in your undergrad, because your advisors set up your classes so that your senior year as an undergrad is really your first year of grad school. So you're going to have those higher level classes to make sure they count for both programs. Again, then giving you that 1 year to complete. Some really great benefits to that is you cut down your cost of school, your time in school. There's also the GRE, which is the graduate entrance exam that you have to take to get into a grad school program. And in the 4+1, we waive that for you, because remember I told you about that GPA requirement. So as long as you maintain that GPA, you've showed us your academic history and that you're prepared for our grad school program. So we do waive the GRE. So if you're interested in the 4+1, once you get to the stage where you are working with your academic advisor here at ASU, just let them know. That way they can help keep you on track for that, so that when you're ready for that, it's available for you.
Yeah. And it's a big benefit in your career. It's easier to get that first job if you have a master's, and lifetime earning, even with an extra year of school. You make almost $500,000 more in your lifetime with a master's degree than you would if you just finished your bachelor's.
Any other questions for us? What kind of programming classes do you take for a computer systems engineering major?
So you take the same core classes, the InterEngineering, or sorry, you do take InterEngineering, but you take intro programming, you take data structures and algorithms, you take, those are taught in Java. Then you take the
Digital
programming
design.
languages course,
Right,
which
programming
teaches you C. Then as you get higher up, it starts to diverge. There's an operating systems class, which both of the degrees take. Then we have embedded systems, which is focused on like programming small hardware, low-level hardware. We have a hardware design class where you design physical hardware for like FPGAs and stuff like that. So it's like doing chip design, but you're using a programming language to do it, which is called a hardware description language. And then the higher level classes are focused on like developing Linux drivers and working with higher level hardware design concepts and stuff like that. So the programming classes during the first 2 years are pretty much the same as a computer science degree, but they diverge after that and specialize in firmware and hardware design.
Any other questions? We'll hang out for a couple of minutes to see if any more pop in. If you've gotten what you needed today, you're welcome to leave the Zoom. And thank you for joining us. We really appreciate it. And you can always reach out if you have any additional questions for us. But again, we'll hang out for about a minute or so. If you have any other questions, you can pop them in the Q&A feature. Is software quality the same thing as testing for bugs?
Testing for bugs is a component of software quality, but there's more to software quality than testing for bugs. Your program should be bug-free, but the quality of it goes beyond that.
So software quality is things like, is it structured well? Is it able to be maintained?
Does it meet performance requirements?
Yeah. Yeah. So not only does it work, but is it good?
What does a data scientist do?
I'll take a swing at that one.
All right.
I was like, don't look at me.
Yeah. So data science. So we live in a world that's rich in data right now. We have vast amounts of data of a scale that humans can't process anymore. And so we need computers and automated systems for processing this data. So a data scientist is going to look at a couple of things. How can we collect and maintain data repositories in a useful manner? And then how can we utilize these data repositories to turn them into information? So there's a difference between data and information. If we have data and we can turn it into information, we can use that to make good decisions, right? An example of this might be, so you've probably all seen Waymo cars and other autonomous vehicles with their little sensor pods all over them driving around the streets of your cities. They've collected enormous amounts of data, mapping data and traffic data and real-time data. How can we process that data and then turn it into information that we can use to control autonomous vehicles, right? How do we get a machine learning algorithm to process that data, turn it into information that can then be used to get an autonomous vehicle to make safe, intelligent decisions about when to accelerate, when to brake, when to veer right, when to veer left? Is that a stop sign or, just graffiti?
If
Okay.
this one, yeah, we got
Go
another
ahead.
one. If I'm debating between computer science and software engineering, how should I start? I'm interested in the 4+1 program. I would check out the two degree pages. So they've got the one at the Poly campus. Actually, both of them are listed on the CIDSE Engineering website. And you can look at the major maps and look at the course descriptions and see if they sound exciting to you. Because one is, about algorithms and you can go down the data science route. The other one is about the process of engineering and how to build big systems and work with databases and all kinds of stuff like that. There's a lot of overlap between them, but they sort of specialize in different areas. And it's really about, what sounds exciting. And if it doesn't sound great, you can always, after a year, you can still switch to the other one, talking to other people, talking to other engineers, talking to the people that, if you come to campus, that are in the degree program. Check out the ASU subreddit and make a question there and say, hey, I'm looking at these two. What do you guys think about the programs? That sort of thing.
Thank you. And what are the future job market prospects for cybersecurity experts? And what program would be best for me for this field?
The prospects are huge. As computer systems become more and more a part of everything that we do every day, security becomes a bigger and bigger issue. And cybersecurity experts are going to be worth their weight in gold. What program would best prepare you for this field? I think there's a lot of opportunity to apply cybersecurity expertise all the way from the hardware level, all the way up through the informatics level where, humans are interacting with the system. So I don't think it really pigeonholes you into any particular program. Again, I would say what area of that spectrum from the low level hardware to the high level side of human computer interaction, where on that spectrum are you most interested? Because you'll be able to apply those cybersecurity skills and expertise at all of those levels.
Yeah. Our computer science program and our computer systems engineering program both have concentrations in information assurance or cybersecurity. And those concentrations, it's the same set of classes for both of those degree programs, and you get a little extra line on your diploma that says that you did the information assurance concentration and stuff like that. And it looks good on a resume, but any of these degree programs can take those classes as electives. And our programs, our cybersecurity opportunities on this campus are fantastic. We have a huge research group, 2 of them actually, that are involved in cybersecurity. We have cybersecurity clubs. We do hackathons and stuff like that. There's a huge amount of that happens on campus, and they're in extremely high demand. The people that participate in those things are in extremely high demand.
Thank you. Any other questions? We still have a couple minutes if you guys want to ask a question. Is it easy to switch between engineering degrees? Yes, it is. So here at the Fulton Schools, you know, they said SITC and then we said Poly School. So there's 6 schools of engineering. All of them house their own set of majors. But it is easy to switch, especially if you're at the beginning of your program, because a lot of those classes will count towards the other major map of whatever program that you're going to if you're within the Fulton Schools. The only risk you run is the later you are heavier into your program and you change, then some of those classes might not count towards your new major map. But our advisors are really great about trying to plug those in where they can. But yes, it's pretty easy to switch. If you are WUI at Poly, do you lose that eligibility if you switch to computer science at Tempe? Yes, you do. So WUI is only offered in engineering on the Polytechnic campus, so those majors that are there. So you would lose that if you moved to computer science. And that's not an ASU thing, that's a WUI thing.
Kim, what's WUI?
WUI is the Western Undergraduate Exchange. So there are certain states that on the Western side that have contracts with different universities. And so they can come in, let's say someone's in California or Hawaii, those are WUI states, they can come in and get a discounted out-of-state tuition rate. So they pay about 150% of our in-state tuition. So it's not quite as high as out-of-state, but it's not quite in-state. And so WUI's offered for engineering just at Poly, and then outside of engineering, I know there's different majors at downtown and west, but none at the Tempe campus.
Gotcha.
All right, so thank you guys so much for joining us today. Again, feel free to reach out if you have any additional questions. But otherwise, thanks again for joining us. Thanks, Phil and Ryan. It's always a pleasure. You guys explain things so well. So we really appreciate your time with us today. And everyone have a great evening. Thank you, guys.
You too. Thanks all.
Bye.